Welcome, Mindsetters, to grade 11 life science. Last week's lesson was on the lymphatic system, and Kathy's going to be taking us today. And you actually can tell us what...
You sat in on that lesson,
I
even
did.
though Indy was sitting here behind the... And you told me you learned a whole bunch.
I did. It was awesome. Like, I found out how the heart works and all the valves and how it pumps blood, and that was awesome.
How you get all that liquid from your feet, and when you're flying, you need to wiggle your toes so your muscles keep moving.
Otherwise,
to push
blood
the
won't
liquid
circulate.
Up. That's right. You see.
Paying attention, guys.
Yes, you can go and start writing life science with the learners.
Exactly.
Hey? There
Exactly.
we go. That's our test. So this week we're doing excretion. And excretion is not defecation, but we will tell you more about that just now. And Ty, you've got some lovely information about learners, they learn extra learners that have done so awesomely, people.
Yes, guys. For those of you who missed it, you need to watch at the end of the show. We're going to be airing the Mazoi story again. Meet the Mindsetter. Awesome, awesome story. Guys, this guy had 5 distinctions in matric. 5. That's a lot. So guys, make sure you're paying attention. And again, Facebook me, tweet me. If you have any questions, if you're lost anywhere on the subject on excretion, make sure you post them on the page and we'll talk to you and get those questions to Kathy. And for now, we're going to take a break and we'll see you afterwards.
Cheers, guys.
Welcome back, Mindsetters, to grade 11 life science. We're doing revision today. In fact, no, actually not revision. We're doing excretions today.
Are we finishing the syllabus off?
Exactly, finishing off the syllabus. So guys, make sure you've got your pens and your pads out. You guys are making notes. Remember, Facebook me at www.facebook.com/learnextra or tweet me at learnextra. And right now I'm going to hand over to Kathy, who's going to be taking us through the lesson.
Ty's so cute, you know that. I could actually take him home with me. All right, people, here we go. We're doing excretion. All right, now, excretion is not defecation. Okay, so what does Kathy mean? Well, defecation means to go and do a number 2 in the toilet. Okay, you do a number 1 and it's liquid. You do number 2, well, you know what that's all about. Okay, and it can be a little bit sniffish as well, sometimes a bit smelly, all right? But that's defecation. That is when we remove waste that is undigested from the digestive system, all right? And that you would have learned when you did nutrition. So it is the removal or egestion of undigested food and waste. All right, that's your roughage and all that stuff. So that is not excretion. We do sometimes call feces, okay, or poo, for those of you that don't understand what feces is, we call that excreta, because it's the undigested, egested rubbish that's out of our system. We only have 4 organs we excrete from. And people, this is exceptionally important, because if I was setting your paper, I would ask you to please discuss the processes of excretion as per the human body. I want you to name the organs that are involved and the substances that are processed, okay? So that is a very nice 8-mark question. So here we go. All right, excretion. We have our organs of excretion, and they are: number 1, the kidneys; number 2, the lungs; number 3, the skin; number 4, the liver. And you're all saying, what? And I'm saying, yeah, look at this. The kidneys, we all know the kidneys are organs of excretion. I mean, that's what this whole section's about. But it's also about the lungs, because excretion is a substance that is toxic and will harm your body if it stays in. Okay, now think about it. If you don't exhale and you are suffocating, what happens? You die. Your cells die. Not only because there is no oxygen for them to produce energy, but Because of the poisons that build up because of the carbon dioxide. And this we will do in detail when we do gaseous exchange, okay? So from the lungs, we've got CO2 and H2O. Why? We need water to get the carbon dioxide out, okay? And you'll note I'm leaving the kidneys for now. Then we've got the skin. Now, the skin is actually very special because it's an organ of secretion and an organ of excretion. You say, can't be both, because secretion, anything that's secreted, means it is a good substance. It's a substance that will aid the body in some way, form, or manner. So secretions are good, whereas excretions are bad. How can the skin be both? Well, think about it. What do we do from our skins? We sweat. What does the sweat do? It cools us down. So the function of sweating cools us down, and that would be sweat is secreted. But the substance that sweat is made of contains excretory waste, and that is excreted through the skin, as well as excess water. So here you're going to have a whole bunch of salts, and you'll have some urea. That's why people stink and smell so bad when A, they don't drink enough water, and B, when they don't wash, because it's all that stale sweat and it's all that urea. It's like having urine under your armpits. Okay, not a happy sight, okay, or thought. So salts and urea, and look at this, H2O. Right, the liver. What does the liver do? The liver undergoes deamination. We did this in grade 10 today. And with the deamination, that is when the liver converts proteins to glucose. So what happens? What happens here when it converts the proteins to glucose? Okay, we're going to take carbons, hydrogens, oxygens, and nitrogens that make up the proteins, break off the nitrogens. The nitrogens plus the odd hydrogens and oxygens make up urea. The odd hydrogens make up urea, and the carbons, hydrogens, and oxygens are grouped into C6H12O6, which is glucose. And the glucose is then used in the body because the glucose, if it isn't used, gets stored as glycogen. And hello, when the glycogen doesn't get used, it gets stored as fat. That's correct. Why? Because fat is so light. Right, so that's the process of the liver, the deamination. Now, the urea goes into the blood. And when it's in the blood, it gets pumped. It's in a state where it can't cause any harm in your body. It's almost like taking all those nitrogens and the bits of hydrogen, putting them into little Ziploc packets, zipping them up, and flushing them into the blood. They can do no harm whatsoever. They get to the kidneys, and the kidneys say, come here, and the kidneys filter out all the Ziplocs, if you can imagine that. All right, all those little waste bags, and it's all in the form of urea. So urea is not soluble. It cannot harm you. So it floats around to the heart, to the lungs, back to the heart, to all the parts of the body until it gets to the kidneys. The kidneys filters out a little bit and cleans a bit of blood all the time. Okay, so your kidneys, all the blood that goes through the kidneys to bring it nutrients and oxygen is the blood the kidneys work with. So if you think of the heart, in the case of the heart is like a butcher. The butcher works with meat all day, but it still has to eat and drink and sleep, all right? And even though he's working with the meat all the time, he doesn't eat any of that meat. He doesn't absorb any of that meat while he's working with it. So the heart has a part of it that's doing its job, but it also has its own blood supply. It has to, because it has to eat, which is its coronary system. Whereas if you look at the kidneys are like, I don't know, like a chef. what does a chef do? A chef works with food all day, and they're tasting here, and come on, you watch Master Chef. They taste here, and they taste here, another little bit here, and have a little couple of spoonfuls here. So by the time they get ready to go home, they are full because they've had all these various mouthfuls that they've been tasting all day. Now that's what the kidney is. The kidney actually gets its nutrients and its oxygen from the blood it works with. So it basically eats on the job. Okay, this blood is then filtered by the kidneys. And remember, urea is in an insoluble state. Now let's look at the kidneys. And what do the kidneys do? They take on water, okay, and urea, and uric acid, and there are so many, we're going to do them in detail just now, and they then filter all that rubbish out, all those toxic wastes, filter it out of the blood, and it goes into the bladder, and the bladder wheezes it out. So you urinate it out through the urethra, but we're going to go through all those structures just now. What I want you to look at here is what is in common. And if we look, let's go with, no, we go with white. Okay, we've got water and water and water, and even in the liver, what's the blood contain? You must remember 90% of the plasma in the blood, because you've got the hematocrit in the plasma is water. So what do we have in common all the way through is water. The only way we can get rid of waste in our body is water. The only way we can control our body temperature is water. And remember, all cells, hormones, antibodies, and enzymes, hormones except the sex hormones, but all cells, hormones except the sex hormones, antibodies and enzymes are made of protein, all right? And we can't have temperatures that are too high, we can't have temperatures that are too low, because if they are, the proteins will denature, and hello, you will have nothing that's working, all right? How do we cool everything down? Because we are homeothermic, we're warm-blooded. How do we cool it down? With water, people, water. You've got to drink water. And by the way, this is Human Rights Day. Respect yourself, respect others, and respect our planet. And if we continue to carry on wasting, and now I'm getting onto my little Greenpeace soapbox, if we continue to keep wasting, you know what? We're not going to have. I'll be dead. Ty, although Ty is old enough to be my child, my son, but Ty would probably be a really old man. And some of you will probably be at retirement age, but your children and your grandchildren won't have water, they won't have electricity, they won't have any kind of resources, and they'll be dying. So we have to look after our planet, people. We have to. If you see a light on and you're not in the room, switch it off. If the stove is on and no one's using it, switch it off. Okay, microwave, don't just microwave things. If it's not hot, if it's still warm, eat it. You don't have to use that electricity. Don't waste. Water, definitely. No dripping taps, no brushing teeth for half an hour while the tap runs. Use a little glass of water, okay? Be conservative, because your children and your children's children are the ones that are going to be without. Okay, off the soapbox. Ty, over to you.
So guys, as you guys heard from Kathy, don't waste. We only have one world, okay? And guys, I hope you guys have been paying attention, because there's a lot happening here. So make sure you're writing notes, you're making those notes, and you talk to me on the page. I just want to say, yeah, guys, make sure you talk. And yeah, we'll see after the break. Welcome back, Mindsets, to grade 11. We're doing excretions today. I also want to say a quick shout out to Kuni for helping us on the page. Thanks you so much. You're so awesome, dude, for helping the guys out. Guys, again, talk to each other. That's why the platform is there. Make sure you talk to each other. And again, respect Human Rights Day. my hand over to Kathy. I'm going to get off my soapbox for a little bit. Kathy, take it away.
Okay, people, remember urinary system is the kidneys. All right, so we're talking about the urinary system specifically. Urinary comes from the word urine. We're going to produce urine. All right, what does it do? Very important, it regulates the water in the body, and it regulates and removes the wastes from the blood. Okay, why? Because if those wastes stay there, it will poison the cells. Because remember, we go cells, and then tissue, organs, systems, and then organism. So if we've got all this rubbish floating around in the tissue fluid around the cells, it's going to poison the cells. All right, the cells will not be able to do what they need to. If there's too much water there, the water will go into the cells and the cells will explode. So that's bad too. You must remember, the body works. I wonder how many of you remember this. When you were little, and you had the story of Goldilocks and the Three Bears. And I'm going to take time out to just quickly go through the story. Goldilocks was, well, clearly Goldilocks was a little brat who ran playing around in the morning. And she came across the strange house. And it was the house where the three bears lived. And, well, being the impolite little brat that she was, she went inside and she just walked in. And there was a bowl of porridge. Okay, I'm shortening it a little bit. There was 3 bowls of porridge on the table. Why? Because the 3 bears, Mommy Bear made the porridge, and they'd gone off for a walk to let the porridge cool down a little bit. Anyway, so Goldilocks, having no respect for her other people, not like us on our Human Rights Day, and she went and she tried Daddy Bear's porridge, and it was too hot. And she burnt her mouth. She tried Mommy Bear's porridge, which was in the middle, in a medium-sized bowl, and it was too cold for her. Then she got to Baby Bear's porridge, and ooh, this was perfect, and she ate it all up. Anyway, she sits on their chairs and she sleeps in their bed, and when they come home, she gets a fright and she runs away. But at the end of the day, that's how our bodies work. We don't like it to be too hot. We don't like it to be too cold. We want it to be just right, which is 37 degrees Celsius. Okay? We want our pH not to be too high or too low. We want the pH to be just right. Why? We'll denature those proteins. All right? We don't want too much water. We don't want too little water. We want just the right amount of water. When you drink too much water, it is bad for you. When you drink too little water, it is bad for you. Too little water, you dehydrate. Okay, and your cells just can't work properly, and you literally become lethargic and sleepy, and you get headaches, and you feel ugh. For you, those of you that get home in the afternoon from school and you got a headache and you feel just like you've got a shell over your head, have a glass of water, and I promise you, within half an hour you'll feel 1,000 times better. 9 out of 10 times it's dehydration. If you have too much water, you end up weeing all the time, okay, and you end up urinating out all your mineral salts. So you end up cramping and not having the right amount of salts in your body, and that's also a problem. All right, people, so not too much, not too little, just the right amount. Find a happy balance. Okay, so we have 2 kidneys, left and right. We have 2 ureters. The ureters come from the kidneys into the bladder. So you have your 2 ureters come into one bladder. Okay? All right? And then the one that goes out is the urethra. Now, how do you remember this? I taught boys my whole life. Okay, 26 years I taught boys only, and I'm going straight to heaven one day just for that. But I'll tell you what, my boys were awesome. Awesome to teach boys only. But this is what we used to tell them. You've got 2 kidneys, all right, 2 ureters, and the ureters, if you look at T-E-R-S, is a soft sound, it's tears. It's like tears. And the little tears drip down. So you have the little tears from the kidneys dripping down the ureters into the bladder. A bladder is nothing more than a storage bag, like a big fat storage bag. All right? That's the bladder. And then the urethra is when you thrust the urine out of your body. Okay, so 2 ureters, which drip, drip, drip liquid into the bladder, and then the urethra, 1, to push it all out of your body. Okay, so very important, you must remember that. They very often ask you, what is the difference between the ureters and the urethra, or a ureter and a urethra? Ureters, kidneys to bladder, drip, drip, drip. Ureters, like little tears, and urethra, you thrust it out. Okay, moving along. Here we go. This diagram you must learn, and I'll ask John to put it onto Facebook for you. Okay, it's the blood system. You've got the blood coming from the heart, from the aorta, and it goes into the kidneys. Now, if you look here, and I'm going to use orange, all right? The blood coming in the renal arteries, okay? That's going to be your oxygenated blood, and your arteries are above your veins, which are lower down. So A comes before V, the arteries are on top, the veins are below, and let's do the veins in purple. All right, they're your veins. And the veins are going to take blood back to the heart. It's going to be deoxygenated, all right? And your arteries are bringing oxygenated blood to the kidney, but it's oxygenated blood and it has lots and lots of wastes and it has nutrients. The blood going from the kidney back to the heart is going to be deoxygenated. It's going to have less wastes, all right? And it's going to have some, or slightly, let's put there, slightly less nutrients. Why? Because, remember, the kidneys eat on the job. They're like a chef. They eat little bits of food on the job. So they're going to take their nutrients and their oxygen from the blood that they're going to be working with. Alrighty, so renal artery on top, renal vein below. Now look here, people, let's use green. Alright, here are your ureters, and they come out of each kidney, so there are 2 of them, and they drip, drip, drip urine into the bladder, and it's called the urinary bladder or the bladder. You can call it, a bladder is a bladder, all right? Urinary bladder, and then we have a valve or a sphincter, which is at the bottom of the bladder, and it's at the beginning or the top of the urethra. And that bladder is what we learn to control when we are about 18 months to 2 years of age. Right, when we stop wearing nappies. Why? Because we learn to control when we want to wee. We know when it feels like, what it feels like when our bladders are full, and we can actually keep it in and then go to the toilet when we're supposed to. So it's all part of potty training. But that valve we can control. And when people get old and they start becoming incontinent, it means that they can't control the valve anymore. Also, when people have fits, that valve isn't controlled. Also, when we have, I'm just trying to think of it, when you get a really big fright and you have adrenaline surge, that valve is released by the parasympathetic nervous system. Why? Because your body wants to make itself lighter so you can run faster, quite literally. All right, so, and then you've got your urethra, which thrusts it all the way out of the body. 1 urethra to thrust. And that's just the way to remember it, please, people. Please don't write thrust in an exam. I think your teachers will have a heart attack. But it's just a way to remember it. Ureters, urethra. All right. This is your urinary system. Here I'm showing you your kidneys. This is what a plate of kidneys looks like. It looks delish. Actually not. I mean, my stomach's turning. I don't want to be funny here. But if you look at these kidneys here, there is the hilum area there. All right? And you'll see it's got a nice shine to it. What would have been here would have been fat. But what we've done is we've peeled that fat off the kidneys. All right? And then the kidneys have a very thick capsule around them. Okay? This is what This is an internal structure of the kidney. We're still looking at here now. What's very, very, very important is that this part, where am I? This part, and I'm going to do it in yellow. This part of the kidney here, all the way around here, that I'm doing in yellow, is a dark, dark red color. It is called the cortex of the kidney, all right? Okay, it's the cortex. Cortex is always on the outside. Medulla is M-E or M-E-D, think of middle. Medulla is in the middle. So this area in white here is the medulla, and what I've done in yellow is the cortex. Now I want to go to my next slide and just show you this. This is a dissected kidney, okay? And what I wanted to do here, now I need a color that's actually going to stand out. All right, here is we've cut into the side of the kidney like this. Now you see all this area that's white? Those are going to be all the tubules. All right, and those tubules are what is colored white here. All right, now if we look at this very, very bright pink here, and I think we're going to have to use white. This bright pink here, that is the cortex. And the tubules make up the medulla of the kidney. So the medulla is on the inside and the cortex is on the outside. The cortex is a nice pink and it's got a rough texture to it. So if you know that your tongue is the most sensitive organ in your body. And I'm not saying that you need to now go and use your tongues to feel it. But if you took your fingers, wet your fingers so your finger's actually a bit soft, and then take your finger and you rub the cortex, it's rough. It's sort of a bubbly texture, whereas the tubules are smooth, and they actually look smooth and shiny. All right, now going back to our slides here. Okay, we've got the cortex, and we have the medulla. The medulla is this region in the middle here. Then we've got pyramids. Now, if we look at these little pyramids, all right, here are little pyramids. And all these little papilla make one pyramid. And it's called a pyramid because it's got a triangular shape. All right? They filter the urine, and the urine moves from here, and it goes into the lesser calyx, into the greater calyx, and then out through the ureters. So this structure here is one ureter. Okay, so let me just ureter there. Now, if we look at this kidney, if this person is lying in front of us, okay, and the kidney looked like that, that's your right side, this is your left side. So if we looked here, we'd be looking at a left kidney. But that's not important at this point. So you've got your cortex, you've got the medulla, which is the middle part, which is light in color. Cortex is dark, so it's dark pink or dark red. All right, the medulla is light or white. Okay, you've got the papilla, which are the little tubules. They make up one pyramid. And here, if we look at this, we've got 1, 2, 3, 4, 5, 6. We can see 6 pyramids. There's the ureter coming out, lesser and greater calyx. Now, please, again, watch here. Renal arteries on top, the renal vein is underneath. All right, renal arteries bringing oxygen. It's bringing blood with lots of oxygen and wastes and nutrients, all of it sitting there in that blood. The kidney is going to take the oxygen, it's going to use some of the oxygen so it can do its job, it's going to take some of those nutrients, and it's going to take the waste and filter that out as urine, all right? And the rest of the blood's going to leave with deoxygenated blood, but there's going to be slightly less nutrients, and it's going to be cleaner than the blood that went in via the renal artery. Ty, are we ready for an ad break?
Yes, we are. But before we do, there was one question from Kashifa, because apparently there was a bit of a trick question in the exam last year. She said that there was a part of the kidney that she wanted to explain, well, an explanation on why certain parts of the kidney is darker than the others. I'm not sure if that makes sense.
That's, you mean the cortex versus the medulla, because the cortex has the malpighian bodies, all right? And that's what makes it rough. So if we look at this, here. Okay, this part of the kidney here, this part to there, this sits in the cortex, all right? And we'll make it green. This part of the kidney sits in the medulla. It's in the medulla in the middle. So if you look here, those are tubes, and those are just tubes, all right? That's why it's got that light pink, smooth texture, just a whole bunch of little tubules. Whereas if you look at the cortex here, it's got this little round structure, it's got lots and lots of blood supply, because look at the blood supply here, all right? And only a very small portion of tubules. So what makes the cortex that dark red color is because of the malpighian bodies, all right? And this round thing here is your malpighian body. Just think of crazy pig, malpighian body, but we're going to do that in detail. All right, so should we go for an ad break quickly?
Yes.
Cool.
So guys, I hope this is helpful. Make sure that you're paying attention, as I always say. Get your notepads out, make notes. I know a lot of you guys are going to be writing some tests soon, so make sure you guys get those notes out. I just want to say a quick shout out to Kashifa and Maggie, and also to Princess and Kulufelo. I see you guys on the page. Awesome talk. And Guni, I can't express how much I'm excited to have you on the page. Your posts are awesome. So guys, we'll see you after this break. Welcome back, Mindsetters, to grade 11 life science. We're doing the excretions today with Kathy, who's going to be taking us through the lesson. In fact, Kathy, I had a quick question from Isaiah. Isaiah wanted to find out, he came across like almost a semi-trick question, and he wanted to find out which of these is not an excretory organ, the skin, the lungs, kidney, or the liver.
Okay, people, the skins, the lung, the kidney, and the liver are all 4 excretory organs. However, one can say technically and argue on a really much higher level that your lungs excrete to the outside, your kidneys excrete to the outside, your skin excretes to the outside, but your liver doesn't. Your liver excretes the urea and the other waste substances into the blood, and then the kidneys filter it out. So theoretically, the kidneys filter out what the liver has put there. So one could then say the liver, but they are all excretory organs. Deamination is an excretion process. Okay, all right.
So
but just, you know what, Ty, I think what we need to actually enforce to our learners is excretion is the removal of toxic substances that are harmful to the body from the body. All right, so in that question, that trick question, I think the liver you could argue, but all 4 of them, what you need to know for your syllabus and what you would get if you were doing anatomy, all 4 are excretory, forms of excretory organs. All right.
I think that was probably the most vital one. I think for now we're good to go. Everyone seems to be understanding. Everyone seems happy. So.
Yeah, and Kuni, geez, you are a star. I'm going to get your email address here, my boy. Just wait.
Awesome.
I'm going to be asking you for all those wonderful diagrams that you've got. Okay, just to recap here, this is our kidney. Please look. There's your cortex. There's the medulla. Medulla is in the middle, all right, and the cortex is on the outside. And why? And it's grainy. It's got a grainy type rough texture, and that rough texture is because of your malpighian bodies. All right, now let's go. Okay, we've got the malpighian body, then we have the proximal, and I'm just going to do this because I want to just show, no, I want space. Let me write here. Okay, this is what we've got.
In fact, Kathy, can I also interject quickly? Because we actually have another very interesting question from Mukoni. He wanted to find out, can the vagina also be considered an excretory organ because of the menstrual fluid that it basically excretes? It's a guy question. It's...
Oh, guys, no. What it is the uterus, there's a lining that builds up, okay? And that in the endometrium, that is a lining, and the lining is there so that if the little egg gets fertilized, it can
implant itself.
And it can, well done, it can implant, all right? So when the egg doesn't get fertilized, you can't just have that lining there for the rest of your life until you actually have an egg that is fertilized. So that lining has to not tear away, okay? And it tears away, and that's where the blood comes from. It's when the lining tears away. So no, it's not an excretory organ. That is a beaut. I'm actually going to put that in my questions
for the next exams.
No. I'm going to put it in those buttes.
in that category of questions that are just too awesome to leave behind.
Too awesome to leave behind, and it's a boy thing. You're right. Okay, guys, look here. We start off. We've got two. Remember, we're working in two parts of the kidney, okay? When we look at the kidney, the macroscopic structure of the kidney, we are going to see that this is the cortex, okay? And this here is the medulla. Remember, medulla means middle. All right, now, we've got part that works here, part that works there. Why? Because in the cortex, we have a hormone called antidiuretic hormone. And in the medulla, we have a hormone called aldosterone. The aldosterone works with the sodium process in the tubules, and the ADH helps with water absorption. And I've got to do ADH with you because it's an exam question without a doubt. Okay, so we start off with this little round buckety thing. Okay, now look at it. It's a little round bucket shape, and then it goes wiggle woggle, and it goes down, it goes up, it goes wiggle woggle, and down. Okay, this one comes along, goes down, it gets thinner. Now, as it goes here, as it goes past this line, it dips in and it goes thinner. Now, anything that goes from thick to thin, and you would have done this when you did the blood vessels of the body, what does that tell you? It tells you that there's pressure. So something's going to happen here, which is pressure. And here, we're going to have, now look at this, we've got an afferent arteriole comes in, okay, and what leaves here and then goes all over here as a capillary network is the efferent arteriole, okay? Now, afferent, remember afferent for arrive, and efferent for exit. So you'll never confuse the two. Okay, so the afferent arteriole arrives at this little structure called the Bowman's capsule. It's a little round, it's like a cup. And it would be like me having this cup and then taking, I've got my umbilical cord here underneath. You see, it's all my wires that I get attached with here. But it would be like doing this and saying, right, I've got, there's my Bowman's capsule sitting in the malpighian body. It's part of the malpighian body. It's sitting in here in the cortex. And it's this little capsule. And then I've got the afferent arteriole arrives into the Bowman's capsule, and the efferent arteriole exits. Okay? They're both arterioles. They haven't lost any oxygen or anything here. There's no gaseous exchange taking place. Right. Afferent comes in, efferent exits. Afferent arrives, efferent exits into the Bowman's capsule, which is here. You must learn all these labels. And it comes in here, and then you have a capillary network and out. That capillary network is called the glomerulus. Something else, if you look here, your afferent is larger than your efferent. So this is bigger, that's smaller. What have we got? Anything that goes from big to small. Come on, Ty. Big to small, we have pressure.
Ah,
do you remember?
exactly.
We did that when we did the cardiac, the whole heart process.
Exactly.
So,
same with the bladder.
Exactly. From large to small. Immediately there is pressure. So here we're going from this big structure, afferent arteriole, into the glomerulus, which is just little capillaries, okay, and out to the efferent. And that causes pressure filtration. Now the filtration part is when stuff gets pushed through here. And that stuff will be everything except fats and red blood cells. Literally everything else gets pushed through here into the Bowman's capsule. Now, that's pressure filtration. That happens in the Bowman's capsule. But there's another thing that happens in the Bowman's capsule. And the inside here, now we need another color. Let's use our green. Lining this Bowman's capsule are little tiny cells, and these little cells are called podocytes. And these podocytes, so we've got pressure filtration because the afferent arteriole is larger than the efferent arteriole, and we have the podocytes, and they are for ultrafiltration. Okay, for ultrafiltration, which means not just filtration, because those podocytes look like, you know these clips that the girls, in fact I've got one in my hair now, but I'm not taking it out, okay? But they sort of clip like this, and the sort of little pieces, the little teeth go in like that. Now those little spaces there is what helps with the ultrafiltration. So only very small particles can pass here into the Bowman's capsule, which means your blood, which is big, fats are big, they definitely do not go through. They carry on here. That's why we don't have to reabsorb proteins from the urine or from the filtrate that passes through here. We don't absorb urine, we don't absorb proteins, have to reabsorb proteins at all. So remember, everything was absorbed by the digestive system into the blood and by the lungs into the blood. Here, everything ends up going into the Bowman's capsule, and that is called your filtrate. All right, now the filtrate goes, and I've lost one of my lines here, and it passes here, all right, and as it gets into this area here, this is the proximal convoluted tubule. When it gets here, guess what? There is an amazing amount of absorption from a high to a low of amino acids, not the proteins. Amino acids can still go through, and glucose, and water, and all kinds of things get absorbed here at the proximal convoluted tubule. In fact, here we have 80% of our water is reabsorbed, and the glucose. So, zhoops, once it's in the tubule, it goes into the capillaries that are wrapped all around the tubules. Then it goes from a wide tube, it goes into the descending tubule, and here the tube becomes small. So there's pressure here. And this structure is called the loop of Henle. And if we look at the loop of Henle, this is where we have our aldosterone working, and aldosterone causes the sodium pump. So what it does is it says, hold on, we've got most of 80% of the water there. We're only going to urinate out 2 to 3% of our water. So what do we need to do? We need to reabsorb our water. So how do we do that? Well, we can't just by osmosis. So what do? We make the area around here full of sodium chloride. So we cause the water to move out. And that is done by the aldosterone. The aldosterone tells the cells to pump the sodium chloride out. The water moves from a higher water potential to a lower water potential, and it's picked up into the capillaries. Then the blood goes up here, back from the medulla, back into the cortex, and this is where we have antidiuretic hormone working. And if there's lots of antidiuretic hormone, diuretic means to wee. Okay, so if there is diuretic means to urinate, to wee. All right, so if it's anti-weeing, it's a hormone that wants to keep the water in your body. Okay, and that's where we'll absorb lots of it. And if we do, guess what? We don't have a lot of, we have very concentrated urine, like on a really hot day. Okay, when we go back here and we say, okay, what happens now? That's where ADH works. How much time have I got? Time? Oh, good lordy. Okay, and then you get here to this part, and there we have what's called tubular secretion. So anything that's in excess in the blood gets put and pumped actively into this part of the tubule. And then this is a collecting tubule, so there'll be another nephron there, another nephron there, another nephron there. So all the nephrons joining together, and that will then form a papilla, which makes up those little pyramids that we saw in the macroscopic structure of the kidney. Now, 3 minutes, 2 minutes, 1 minute.
1 minute.
1 minute 20. Sorry, Ty, you're just going to have to fuss bait here. This is ADH. Okay, hot day, cold day. I'm going to put this up for you guys. Hot day, cold day. Hot day, we need more sweat. All right? If we need more sweat, we need more water in the blood. Okay? Please, you're going to have to live with my handwriting here for a minute. So, more water in the blood. Why? Because we want to make more sweat. So, more blood in the, more water in the blood, and therefore we are going to have more antidiuretic hormone, which means we're going to end up with more concentrated urine. Okay, that urine's going to have less water. On a cold day, what do we have? We have exactly the opposite. We need less sweat, so we need less water in the blood. So why? We're going to release less antidiuretic hormone, and therefore we're going to have dilute urine. Okay, and that's when you go for a wee every 5 minutes because you've been drinking too much tea and coffee. There you go, Ty.
All right, guys, in the nick of time. Yeah, so guys, make sure you guys were writing notes down, got this information. There will be a repeat of the show over the weekend. So guys, I hope this show helped you a lot. I'm seeing a lot of you guys, Nolu and Zentle, I see you. Klanka, I'll try my best to find out if we can help you. And guys, we'll see you next week. Or not next week, on the 16th. Bye.